So we have the next derivation now, which is of root mean square value or RMS value. Okay. See, we concluded in the last lecture by just reading the definition. Now let's start in detail. So it is defined as that value of direct current. Make sure the word to write direct current here. Okay, which produces the same heating effect in a given resistor as it is produced by the given alternating current for the same time period. Now, what is the relation between the effective and the peak value of alternating current? See, we know we were talking about the word heating effect. So we already wrote from the class 10th formula, that is H is equal to I square RT. Now if I have this formula H is equal to I square RT, and if I have to put small change in the heating effect, then I will be putting the small change in the time period, right? Now, if we have to integrate both the sides, then this integration sign will be getting cancelled with the derivative word and we are getting only H. So, the total heating effect is equal to the integration of I square R dt from the time period 0 to capital T. Clear? Now, we can also say that this I value can also be written as I effective square R into capital T, right? Because after integrating, we will be getting the value I square R dt and 0 to t, right? This dt will be turning into t only, and if we will be putting the value capital T here, we will be getting capital T minus we will be getting 0 here, so this I square R into 0 will turn the answer 0. So that's why we are not mentioning that. Clear? Now, next thing we have is, if this value of I square effective R into T can be written in place of H and will be equated to I square R dt from 0 to T, we can equate this. We can see that R and R will be getting cancelled. So this I effective square, I took it here. Now this T value, see what I am doing, I am just taking this T value in the denominator here, integrating it from 0 to T, then I square R, I square into dt. Now this I square multiplied by dt will be getting integrated to calculate the value. But before that, we have to put the value of I in terms of I naught sine omega t. Okay, so we can put it. This I will be I naught sine omega t whole square. So square and square coming here, and this dt will be dt itself. And this 1 by t will remain as it is, integrated from 0 to t. Clear? I naught square is a constant term, will be taken outside. But the integration of any sine square theta term, we will be mentioning from the formula, that is of trigonometry, that cos 2 theta is equal to 1 minus 2 sine square theta. This value I can take here. So it is 2 sine square theta 1 minus cos 2 theta. This 2 value I can take in the denominator. So I am getting the value of sine square theta as 1 minus cos 2 theta by 2. Clear? Now we can just separate this value, that 2 will come here also and here also, and then I'll integrate. So 1 by 2 multiplied by the dt, integration will give me the answer t, right? And this cos 2 omega t divided by 2 will give me the answer cos will become sine, 2 omega will come in the denominator. Okay, now see what I have to do now further. We will be substituting the limits from t and 0. We substituted that I naught square t will be coming as it is. First of all, t I will be putting here and 0 I will be putting here. So I am getting t minus 0. Okay. Now this 1 by 2 omega I can take outside and I will be putting the value t here. So I am getting 2 as it is. So 2 into omega will be 2 pi by capital T multiplied by t. So I am getting 4 pi by capital T multiplied by the value t. Okay. Then I will be putting minus sign and I will be putting 0 in place of small t. Clear? So now we are getting I naught square by t as it is, t as it is, minus 1 by 2 omega as it is, sine 4 pi and multiplied by this t and t will get cancelled, will give me the answer sine 4 pi. And as soon as I will be putting the value 0, so this whole term will become 0. So I am getting I naught square by t into t then this term will also result the answer 0. So 0 minus 0 will be 0. 0 multiplied by anything will be 0. So now I am finally getting the answer I naught square capital T by T, and from here, from this 2, I am putting from here, see, from the earlier thing now, this 2 will be taken outside. So this we will be writing in the end to avoid any derivation issue. Now this I effective square is equal to I naught square, and T will get cancelled, and I naught square by 2. So now if I deduct this square root, then I will be getting here I naught, and in place of 2 I am getting root 2. Now root 2 value we know numerically is 1.414. So 1 divided by 1.414 will give me the answer 0.707 into I naught. Okay. So in the same value we can write E RMS, which is again the same thing. So I am repeating the summarized pattern again. What I took, the DH value, I equated this to the I effective value. Equated. Now we integrated and took this T in the denominator. Now I substituted the integration value of sine square as 1 minus cos 2 omega T by 2, and then integrated by taking 2 outside. So you can write 2 outside in the similar pattern everywhere, so that you will not be getting confused. Okay. So let me mention this everywhere with a different color, that we took 2 outside. Okay. Will be easier to you. Okay. So now I am getting this whole answer. So if I was calculating the answer for average, that will be 2 I naught by pi is equal to 0.637 I naught. And if I am calculating the value for I effective, that will be 0.707 I naught. You have to cram it, learn it. Now we have certain questions to be done. Let's analyze one question. The electric mains in a house are marked 220 volt and 50 hertz. So as soon as I will be getting to read this portion, I will be getting that this is the value of E RMS and this is the value of frequency. Make sure this thing. Now they asked to write down the equation for the instantaneous voltage. Instantaneous means exact the value of E. And we know the relation that E is equal to E naught sin omega t. Right? E naught value I can substitute as root 2 times of E RMS. I already concluded from the previous formula. See, from here we concluded. Right? So E naught value I can write root 2 into E RMS. Okay? So I substituted the value root 2 into E RMS, sine and omega value I can write 2 pi f, and t will be as it is. Why I wrote in terms of f? Because they have given us the frequency. Okay? So root 2 value I substituted 1.414. E RMS I can write from here 220, sine version of this whole thing, and we will be solving and getting the answer. Similarly, I have one more question. Let's do that. The electric bulb operates at 12 volt DC. If this bulb is connected to an AC source and gives normal brightness, then what would be the peak value? Peak value means you have to calculate naught word. Okay. Either I naught or E naught. If they will be mentioning the value peak. And here they have asked for E naught. Okay. Because E RMS they have given. So this value at which the particular thing will be operating now, that will always be written as RMS thing. So this is E RMS, that is 12 volt. We know the relation E naught is equal to root 2 times E RMS. So that will be 1.414 multiplied by the E RMS, that is given as 12, and we are getting the answer. So now you have further questions to solve, then we'll start with the phasor diagram in the next lecture.